Hey everybody, and welcome to McArdle Math Academy. In this video we're going to do an example involving trigonometric substitution for this integral, all with respect to y. So when you look at this integral you might think that normal substitution will work, but then you'll find that that doesn't get us anywhere, and partial fraction technique does not help either. So we're relying on trigonometric substitution to do this integral. Now because it's of the form a squared plus u squared, we're going to need a tangent substitution in this case. And we know that there's a different protocol for tangent substitutions and sine substitutions. So this will illustrate the tangent method. So what we're going to do is we're going to set up our triangle. And what we do here for the hypotenuse is we write the square root of 100 plus y squared. For the height, we'll have y, and for the base, we'll have the square root of 100, which obviously is 10. Now from this triangle, we start with tangent. So you're going to write tangent of theta to be opposite over adjacent. So you get y over 10. We're going to solve that for y to get 10 tangent of theta. And then we take a derivative. So we find that dy is 10 times secant squared of theta d theta. Alright, and now we need a few more things from our triangle. So what we're going to do is we're going to solve for theta. From this tangent equation, we see that theta is arctangent of y divided by 10. And we know that anytime we talk about inverse trigonometric functions, we always have to restrict the domain. So let's keep that in the back of our minds as we move forward. Also from the triangle, when we look back to our original integral, we see that the 100 minus y squared is going to be something that we'll have to get rid of when we make our substitution. So I'm going to use a little bit of a tricky technique here, where we're going to use the triangle to solve for 100 plus y squared. So you'll notice that secant theta is equal to the square root of 100 plus y squared all over 10. That's hypotenuse over adjacent. We solve that for the square root of 100 plus y squared, and then we can square both sides, which gives us an expression for 100 plus y squared in terms of theta. And that's going to be really helpful for us when we go back to make our substitution. So this is all we need from our triangle for the moment. We go back to our original integral, and we're going to make some substitutions. So for y, so we'll start with the y squared term. We're going to use this equation for y, and we're going to plug it in, so we're going to have to square it. So you'll notice that we get 100 tangent squared of theta. And then for the red piece, 100 plus y squared, we just found that on the right over here to be 100 secant squared theta. So we'll write that in red. Okay, and then finally, let me get another color here. We have dy. dy down here is 10 secant squared of theta, all with respect to theta. Okay, so we used our triangle to make a complete substitution from the y variable to theta, and our new integral is only in terms of theta. So it's cleanup time. The secant squareds are going to cancel, the hundreds are going to cancel. You're going to be left with 10 tan squared of theta, all with respect to theta. Okay, so to finish this integral, we're going to apply a Pythagorean identity on tan squared. So we know tan squared is equal to secant squared of theta minus 1, all with respect to theta. And now we're going to split this integral into two pieces. So we have 10 times the integral of secant squared theta with respect to theta minus 10 times the integral of 1 with respect to theta. All right. Now, both of these integrals are pretty simple. The second one obviously is a little bit simpler. So that's 10 minus 10 theta, all plus 2, excuse me. And now this first piece, to find the integral of secant squared, that should ring a bell. And why should it ring a bell? Well, we know the derivative of tangent is secant squared, which means that the integral of secant squared should give us back tangent. So we actually do know this in a way to be tangent of theta, and you have that 10 out in front. Alright, so let me erase this. So our final step is to go back to x's. So we're going to take this. This is 10 times tangent of theta. So we go back to our triangle to figure out what tangent of theta is, and that's y over 10. So tangent of theta is y over 10. Then we're going to have minus 10 times theta. And we go back to our triangle to figure out what theta is, and theta is arctan of y over 10. So we'll write that in blue here. Arctan of y over 10. And all of this is going to be plus c. And again, we just clean this up to get our final answer, which is y minus 10 times the arctan of y over 10, all plus c. So let's zoom out here so we can get a big picture of the procedure that we used. We can see that we did all this work in the beginning just to figure out the relationship between theta and x, or theta and y in this case, and we use all of this information that we dissected from the triangle to make our substitution. Once you make your substitution, your new integral will only be in terms of theta. You can solve that with normal elementary techniques, and then in the end, once you have your antiderivative, you make a substitution back to the original variable of y, and that's how we arrive at the final answer. Alright, hopefully this helps, guys. I'll see you next time.